Hi everyone, this is a continuation of the previous video on implementing stacks using linked list. I am Vikas Bandaru, and this is what we have covered so far. We saw the basic design of a linked list, and we have seen how stack follows LIFO order, and we have seen some real world scenarios, and we have also seen the push and pop are the base operations of stack, and we try to see what are the different linked list operations uh, are available. And so our next step is trying to observe which of these 6 operations can be used to implement push and pop. So let us choose these next things. Okay, so here as part of the linked list operations, we are taking an example of insertion at beginning and deletion at beginning. So here, as you can see, this is an insertion at beginning. This is the main list where I'm trying to insert a new node or new element, and for that I have to connect this new element to the list, and then I have to make head or start as pointing to the new node, and we will get this element inserted into the list. In the same way, if I want to delete an element from the list, let us say this is the list and this is the first element. If I want to delete this, all I have to do is first I take a temporary variable which will point to the first node of the list, and then I will make the current start, which was actually pointing to the first node, to make it point to the next node. And so now this becomes the new first node of the list, and this gets disconnected from the list. And once this gets disconnected from the list, all I have to do is supply this temp pointer variable into the free method, which will deallocate the memory assigned to this particular node. So how these two operations are related to stack. Let us try to compare stack operations with linked list operations, the two operations that we have seen just now. So here, as we know that push inserts an element at the top and pop deletes an element from the top. So if we say that top is something which is pointing to the last element pushed into the stack, then that top will keep track of which element needs to be deleted. So if we say this is our linked list, where I have just changed the name of the start or head, which will be pointing to the first element of the list from the previous slide. And now, as you can see, this pretty much looks like stack, because top is the pointer which is pointing to the first element of last element inserted into the list. And now if I manipulate this, whether I add a new element here or I delete this element, if I can move this top above or below, maybe this will act more like push and pop. So let us see. If I do this insertion at the beginning, as you have seen earlier, there is a new node, and this new node is connected to the existing list, or in our case, if we consider this as a stack, we are connecting this new node to the existing stack, and then making top point to the new node, and all of a sudden this becomes the second element and this becomes the first element. And so insertion at beginning of linked list can be called push of stack. In the same way, let us take this example where I have a particular linked list. Now I have inserted 2, and 2 has become the first element of the list or first element of the stack, and now top is pointing to the first element of the stack. I want to delete the first element of the stack. That means I want to pop something out of the stack. Then I have to take a temporary variable pointing to the topmost node, and then I make top point to the second element of the list or of the stack. And so as you can see, now this element is disconnected from the stack and it is being pointed by temp all I have to do is deallocate the memory assigned to temp using free of temp. And so deletion at beginning can be considered as pop of stack. So if we can implement the program of these two operations, insertion at beginning and deletion at beginning, and somehow give names in such a way that they are considered as push and pop methods, push and pop functions of stack, then maybe we can implement stack using linked list. Okay, so in the next video we will see how to implement these things as in a C language and implement stack using linked list. Thank you.